Good morning, friends. This is the next class that we are going to begin. Now, if you look at the syllabus, already we have gone through in the first class, right? This is the second class. We are going to begin with the first chapter, that is an overview and critical system and software process. So when we talk about the overview of the software engineering, and professional ethical responsibilities, socio-technical systems, right, and organization, people, computer system, legacy system. There are many things we talk about that, and we'll be spending around 7 hours of time on this. And your internal exam one is based on that. That's what the performance engineering measures, critical test, and test speaks about that. Okay, we are going to cover all these things, right? Um, right. So let's begin with the uh, about the system. We'll try to know about the system. Already in object-oriented systems, we have spoke about something about the system, its complexity and all. Let's revisit that here. Now here, when you look at that uh, uh, scope and necessity of software engineering. So this is again repetition, right? Assume that you are building a small wall of 3 bricks by 3 bricks, right? Then what are the complexity involved in that? You can very easily build this particular wall. But when we go to the big complex and all, or the big bridge and all, big system, right? Then we find it very difficult, because of the complexity involved in that. And we all know that one complexity here is beyond human intellectual capability. So we need to work with the system, multiple people in a system, that we need to work in an organized manner in, which we need to work. And this organized way of developing a product, will be seen in software engineering. What are the different phases and all these things, we will see, look into that, right? And the another interesting thing that you find, about the software engineering, here's a small cartoon which would like to show to you. It speaks about the how what is a kind of a mismatch between the customer, developer, designer and all, how it get into shown in the form of the cartoon. So when you as an analyst, when you as an engineer approach a customer explain about the system, and that's how it looks like that. It is the explanation. You try to visualize the explanations, textual explanations given and all, right? And when you look into uh, uh, right, how the project leader understood, right, whole the system. Now this, it doesn't happen exactly like this, but there will be a lot of mismatch between the customer, what they explain, and the we as analyst and designer understand that when capture the requirement and store it. If we do not capture the requirement properly, if we do not store, I mean, precisely write the requirement of the customer, then the system goes in a wrong direction, and it may not be acceptable to customers and all. So there is a mismatch always, omission, error, ambiguous statements, all kinds of things that happens in requirement collections, right? Now when we look into that's how the engineer design it. So if at all we do not capture the design properly, it may so happen that we may go wrong, right? So though it appears in a cartoon like this, yes, a lot of things when we design, things go wrong, right? In object-oriented system design, we spoke about, right, uh, cohesion and coupling. If the systems are not highly cohesive and all, things go wrong. All these things we will try to see it when we get into the different chapters, where we speak about the design and all other things. The design, when we look at the design, we get into the traditional design, about, is a flow chart, then system chart, right, then algorithms, then we have a ER diagram, process diagrams, state diagrams, like this. There are different kinds of diagram that we get into, class diagrams we get into, through which we try to capture system behavior, right? Whatever that we understood from customer explanation, which we translated into the form of a software requirement specification, we try to design. right? If the requirements are not captured properly, the design will go wrong, and certainly it's going to go wrong, right? Because the system which you are going to build is a complex in nature. It's highly complex, highly voluminous in nature, right? And that's the reason, right? And it's being beyond human intellectual capability, though we work in a team, right? But a complexity, okay, if not being addressed properly through the appropriate strategies of the design, okay, appropriate paradigm, appropriate programming paradigm, appropriate documentation procedures and all, things fails, right? All these things we are going to see it today. Just I'm going to introduce about, okay, system. Now when you look at the programmer, people wrote like this: you need to be a very good programmer. Though the programming is the last and least important activity in system development, but right? Yet, your role as a programmer, your role is to translate the requirements and translate the design into working systems, right? So, if you're not good in terms of programming paradigm, right? If you're not good in, okay, programming styles, programming performance related things, and many other quality parameters that we will see it, right? So, okay, things, okay, go wrong, right? System doesn't work, right? System work, okay, in a compromised way, right? There are a lot of missing components in that, lot of things which do not perform well, right? So that's how it gets into. That's why this cartoon, this particular, okay, diagram that it is shown here, right? Now when you look at okay, sales executive, right? When people go to the customer, they describe how well the system they developed it. They described in this way, though the development is something different. This is the best cartoon. People, you know about that. You might have seen it in your WhatsApp group and internet also, right? They explain about that. And when you explain and people, customer do not get according to your explanations about the product and all, there's a lot of mismatch. You lose customers, right? So you need to have a good, okay, capability to convince the customers. At the same time, you need to be, okay, telling about the true feature of the product, right? Thus, then how project was documented. When you look at the documentation, people, it may be a technical manual, it may be user manual, it may be design manual, it may be manual, it may be a report containing software requirement specification, it may be traceability aspect of that, it may be design documentation, right? It may be test cases, test procedure documentation. When you look at that, okay, if it is not well organized, many people, they are good in programming, but they do not document whatever they do. They are very lazy in that. Okay, if you are lazy in documenting whatever that you are doing, whatever the good, okay, components you are developed is of no use. So documentation plays a very important role, right? When you go for the product level, okay, developments and all. If at all you're doing small programs like a quadratic equation solution for that C program, which you are saying, they're not product. Okay, they are an exercise. They are the beginners, how they understand programming language and all, right? But these are all complex things. Documentation plays important role. But when you go for the operations installed, okay, it may not be well, okay, installed, deployed at appropriate site. Some deployment may go at the server side, some deployment may go at the client side, some deployment at the middleware kind of things, right? That makes whole environment. So you are programming is not only the product development. So you have a requirement engineering, you have a design related aspects, you have a programming related, you got a, okay, managing resources, managing people, okay, preparing documents, right, and deploying the product and maintaining the product deployed. All that, all are equally important, right? So you need different varieties of skill set that is required. Whether all skill set you have it all, multiple caps you wear on the top of your head, or multiple people involved in doing all those things, that's how the organization function, right? And you need to work in heterogeneous team, right? So then how customer was built heavily, okay, done something, built heavily, and this becomes a cause for, right, the mismatch. I paid and I said that what is that I want, but you didn't deliver what is required, right? And when it comes to the supporting during the maintenance, right? There are two types of maintenance that usually we get into: corrective maintenance and adaptive maintenance, right? Corrective maintenance in the sense there are certain flaws, okay, the customer identify, or the product get released with a known flaws. You try to do corrections and release the patches, right? This is one aspect of maintenance we call as corrective maintenance. Whereas adaptive maintenance in the sense when product is deployed and customers start using this, okay, they wanted a new feature. A change is a constant all the time. So next Monday, next month, okay, they find that one a new feature, new services they wanted. Okay, as a okay, then they speak about as a new requirements and all. You implement all those things. This becomes adaptive maintenance. Your old product, right, adapt to the changing requirements and all. So the design comes into picture, programming comes into picture. How do your design, how do your programming, right, paradigm or otherwise whatever that is there, documentation, right, okay, facilitate what is called maintainable code, maintainable design, and all these things. I told you maintenance are of two type: corrective maintenance and adaptive maintenance, right? Thus, so, but finally, when you look into that, customer really needed something which you captured in different way, which you developed something hi-fi things, something you build, okay, very high, okay, high, right, and not developed to meet the customer's requirement. So always, okay, there will be a mismatch. However professional you are, right? Customers intent, customers requirement capturing is an art, and that's what we say it as a part of requirement engineering. Okay, all these things are true, though it is projected as a cartoon. They all these things are true in product development, because product is a very complex system. It is beyond human intellectual capability. Though we work in a team of say 5 people, 10 people, 20, 25, maybe 100 people, depending on the size and the complexity of the system, but yet they all, okay, complexity is beyond human intellectual capability, right? So you understood that one, why it happened so, right? There is a mismatch between what is required and what is that we have understood that it is really required, right? If there is a mismatch, our design, our programming, product development, okay, going the totally wrong directions and all. So every phase of product development is an important thing. So now I'm going to show you one clipping, though I have shown it in object-oriented, okay, session, but yet I wanted to show to you because it's a part of completeness. So I wanted you visualize this as a system and see that one, okay, system is made up of, okay, several components, subsystems and all. Finally, at the lower level, smallest possible component which is working, which is coordinating, which is synchronizing, which is sending messages to different coordinating systems and all. So it works, so the subsystem works, so the whole system works. The coordination, synchronization, calling one services by other components and all, together providing a services at lower level, at the abstract level, at the systems level. All this is to be visualized as a product when you look a system, when you look it. I wanted Abhishek, right? Tell me whether you can see this video clipping on your screen or not, right? 1 minute, you wait. Look at that. It doesn't have audio. Abhishek, I think it's visible to you.
Yes,
Abhishek,
sir. Yes, sir.
yeah. All of
It's
you
it's
see this. This is really one of the good video which is being projected in mechanical department of some primary institution. Now look at that. Coordination, cooperation, everything has its own responsibility. Highly cohesive. Wheel will function as a wheel, but wheel, okay, coordinate with some other components. Steering, braking system, gear system, right? Fuel, automated, okay, services there, monitoring systems. See, look at the coordination, timing, synchronization, operations, automation, sequencing, ordering. I'm not advertising, okay, any vehicle here, right? But what is that I'm saying is, okay, when you look at the four-wheeler, right, it is a system, right? It is made up of several subsystem made up of different components are made up of small objects and all, right? Small object capture certain behavior. They are highly cohesive. That means they are designed for single purpose. Nice. They live together, they coordinate with each other, and finally subsystem works, finally system works. Synchronization, coordination, responsibility, sending message, ordering, sequencing, sending message, all that makes system. So you as a designer, you as a okay analyst, you need to capture, okay, every aspect of product working, right? Abhishek, the video is completely visible to you.
Yes, sir. Yes, it was
That's
completely
good.
visible.
That's good, right? That's good, right? So you need to visualize, your mindset should move from writing a program for quadratic equation to, okay, thinking such as a system which is bigger, several components, several subsystems, several tables and all, several user interface, right? Then subsystems, components and all, right? Several objects, right? So in that way, when you look into that one, then you need an organized way of gathering requirements, designing organized way of designing, organized way of developing program. See, in first year you have developed alone a program, so assuming that you are not copied, should not copy, right? Otherwise, if you copy, you don't get an experience. When you don't get experience, your placement, okay, fails, okay, this one. And when you join industry, due to, if you tell you manage some placement somehow, when you go and join, okay, organization industry, you find it difficult because at the time you have developed yourself with by copying so many things. So best, I mean, thing is do everything on your own. The copying one will kills your ability. It will make you disable. It will disable all your capability, right? So when you develop on you own everything, right, things go good. In first year you have developed a small program, but now hereafter you will be visualizing a product of, okay, maybe hundreds, several hundreds of lines, several, okay, more than multiples of tens of things about the components, subsystems, okay, databases, tables, right? Several user interfaces. When you look into that, so you alone cannot work. You need to work in group, and you need to divide the work to different people and assemble all the things, coordinate all the things. People management, resource management becomes an important aspect of any product development. Today, I'm introducing, right, what is that we are going to study in totality. We are not yet started, right, our first chapter, right? Okay. Now, and I told you that one, it is true. Product, okay, okay, is a complex and is beyond human intellectual capability. And when this complexity you manage, productivity increases because productivity is inversely proportional to complexity. This already I have told you during object-oriented sessions and all. So you need a, okay, systematic, organized human coordination for documentation, for understanding, for programming, okay, all the things, right? That is a people management that you need to manage complexity. You need at the same time, right, programming paradigm. Object-oriented programming paradigm is currently the one which people talk about, well organized, okay, way to deal with complexity. Thereby, it increases the productivity. That's how it looks into. We are going to study about object orientation in, okay, for third or fourth chapter also. right? So I'll skip some of the things that which already I told you. And I told you that, okay, complex software complexity, when you don't deal, right, it results into total breakdown. We call it as a crisis. And crisis, software crisis, okay, are being categorized by three important things: late submission, over budget, deficient in their stated requirements. All these things you have to pay penalty to the customer. You late submit that today you are supposed to release one particular component, you don't do that, and people wanted to use from the Monday, right? And they say that one every day, every hour, at the late submission you do that one, they charge these many dollars per hour. You have to pay for that, and that will decreases your, okay, profit margin, right? And you wanted to, okay, if you do not plan properly, right, what happens is that when you are deployed 10 people and deadline you are not meeting, then you employ more people, 2 more, 12, right? Then you have to pay extra, your profit margin comes down, right? And you don't do all the things in hurriedly manner. You develop something, and something you don't implement and release it, and later tell the customer, sorry, we did like this, and do that. You lose your brand, you lose your reputation in the market. And okay, you having released, okay, product to customer which are deficient in their requirements, some of the requirements are not being built. So this is how a complexity results into that, right? So now how do you manage complexity? And today talk about the quality. That's what it is there in your first chapter, right? So when you talk about quality, three dimensions of the quality. See, whenever the session ends, okay, end of the class. See, there are three important dimensions of uh, quality. One is operation dimension. Okay, hope, okay, you are seeing all these things here, right? Operation dimension, transition dimension, revision dimension. When you look at operation, correctness, reliability, efficiency, integrity, usability, we'll see all these things. When you look at the transition, all this is required. Operational aspect, it's a old one. But today, what is more important is your product portable, reusable, interoperable? All these things terms we will see through examples, right? Through examples. I'm just introducing to you. Then revision. How can I develop a product so that is a maintainable, it is flexible, it is testable? I can test the product very easily. I can locate, right? What are the strategies required for that? So these are the three dimensions of quality that I need to look into: operational dimension, transition dimension, revision dimensions, right? Whether these, it is simply programming doesn't make sense today. So any term or henceforth you do, or any project that you do, please ensure that you give a key importance for all these things. Today at 7 o'clock in the evening, yesterday we were supposed to, but today at 7 o'clock, okay, we are meeting and explaining about the project related things. Please join, right? So Ashish, okay, and Ankit of B division, right? They are coordinating this and making, okay, that session. Please join to all these things. Don't miss it, right? If you miss that one, people may say that is a theoretical subject. No, right? Once we get into deeper into the different chapters and all, you will be getting different examples, true examples, real life examples, right? Usability, we take a real life examples, right? Reusability, right? We take a real life example, you will be coding for this, right? Okay, we talk about maintainability, testability, you will be doing it. There will be assignments for on this, no theoretical stuff. And already we have started in a Google group, classes, Google class, a few basic assignments. I wanted you people to do it. So this is the, okay, the quality dimensions of a product, right? And see, when you look into that, uh, there are different aspects. Customer needs is there, then you needs are getting translated into requirements, requirements are getting translated into design, design is getting implemented, and the actions, whatever that you see, that becomes a software product. If needs are not being understood properly and captured in software requirement specification, SRAs, design will go wrong, and what you code go wrong. So the verification activity is very important, where requirements are being translated into the proper design or not, that you will see it. Then there is another term that we use, validation. So when a product is ready, okay, we look into, okay, what is the customer needs. We try to, okay, check the feature of that with the end user needs. So that is the term we use, validation. Okay, validation, we are validating the service, okay, you have implemented, okay, against the needs expressed by, right, end user, customer, client, whatever that you call. And during development in your chamber, I mean development chamber, right? Okay, whether you have captured needs properly in the requirement, every requirement is correct or not, every requirement is translated in proper design or not, design is maintainable or not, flexible or not, testable or not, right? Okay, this particular thing, correctness, whatever that you do that, it is a verification activity. These are the standard worldwide use terms. You must use these terms henceforth to explain about that. So we introduce the term, right, verification, where design is done properly as per the requirements. You check the correctness of that verification. And when a product is ready, okay, you try to look into whether it fulfills all the needs of the customer. Okay, that is a validation. And please look into that. Customer may not be happy because your requirements are not properly okay, captured, or needs are not captured properly in the form of requirements, and this mismatch is going to be there all the time, and you cannot blame customers, right? So this is the one which, okay, not understanding the needs of the customer will make system to collapse, right? So that's how it gets into, okay. The another aspect which you are going to study, I'm just introducing that, right? um, in software engineering you are going to study, okay, different aspect. When we talk about the software process, development process, product engineering process, and process management process, so there are certain procedures, there are certain culture, there are certain ways in which it is to be done that undergoes changes, right? So traditionally, whatever that you see today, right, whatever we teach, right, that is a waterfall model, spiral model, something we talk about that, requirement engineering, design engineering, okay, programming paradigms, testing, deployment, we talk, right? V and V model, we talk. We'll come to that, right? And nowadays, people are talking about the agile practices, how quickly I can develop, right? This, right? So this is all process management process. We look into that. But whereas product engineering process, when you look into that, there are three important things. Development process, right? Requirement, collect it, design properly, do programming, test it, okay, deploy it. Then the another important aspect is that project management process. As a part of a development, okay, you have to properly plan about the cost. I mean, estimate the cost, plan about the schedules, plan about the deliverables, right? Plan about the resources required. When, what kind of resource required? You want particular software resource required, okay, next Monday. You cannot, okay, procure that one today because it is costly. You cannot hire it. Hire the people in advance and make them to sit on the bench. People management, right? All these aspects come into picture. So project management is a very important thing, right? This. Then other one is configuration management. Okay, you develop different versions of product, component, objects, small piece of code. Different versions are there. How do you manage that one? So when you buy Oracle 12, right, don't think that one Oracle 12 as a one piece is made available to you, right? So there are, Oracle 12 may contain, right, one of the component which was there in Oracle 7 also. So when something is required, it bundles all the things and that bundle is made available to you. Okay, thus, right, there are different versions. Some component, okay, may undergo the revision, right? How do you manage versioning and all these things? That is very important. Version management, configuration management is one of the important aspect of that. On the top of all these things, right, as a part of the project management, you will see the risk. Risk is a situation where, right, non-availability of something will hamper, okay, your deliverables planned. Non-availability of anything. It could be people, it could be software, right? It could be any resource, right? Whatever it is. So risk assessment and its mitigation. For example, I need an expert on a particular testing tool next Monday. I don't have it in my organization. I need to hire, and somebody has promised to come. But if they don't come on that, then all my work will get hampered. So I have to pay penalty for that. So I need to classify such a kind of risk severity. Is it low, medium, or high? And I need to have an alternate plan for this. Right? If that person doesn't come on next Monday, what should I do? I need to have a plan B so that I do not stand still. So all this aspect make this particular course, and we will see all these things in the next class, and actually the chapter that we will begin in the next class. Right now, okay, I wanted the floor, okay, to discuss on that. I request all the people, if you have any questions on this, okay, you put in a chat box, and I wanted Abhishek P, right, unmute, read the chat box and ask the question. Questions will be read by Abhishek P. Abhishek P, unmute.
Yes, sir.
Now all people, right, mute except Abhishek P, right. If you have anything to ask, put question in the chat box. Put the question in the chat box, and Abhishek P will be reading that. There are totally 66 students have participated. Any questions from anybody? Thus, I have introduced the course, not yet started the first chapter. Abhishek P, you can unmute. Abhishek, right, that's good. Read the chat box and read the questions to me, if at all anybody has.
No, sir, there are no questions.
Anybody, they can openly ask me. You can unmute one by one if anybody has. And all this video recording of this, whatever I spoke, I'm making it available in Google Class. You can run it and play it. And PPT, whatever I have shown you, those PPT also, I will convert that into PDF, and I'll make it available, okay, today evening. For every class, okay, on that day evening, it will be made available in uh, our Google Class. You can go through that if at all you are missed. But the very important thing is you need to attend the class. That is most important thing, right? Once we start the second chapter, and then after, right, or even in the first chapter itself, right, there will be a lot of exercises we take it, real life exercises. This is real life exercise we take it, right? When we talk about the usability, we take one interface, whatever that standard product has, and we try to comment on that. And in the examination, you'll get some other user interface which neither you have seen it nor I have seen it. So in that way, attending the class becomes more important. So any questions? Otherwise,
Excuse me, sir.
please,
Sir,
please.
there's a question. How is it different production machine and development machine?
Okay. See, now look at that product. Here, you're talking about this particular diagram shown on the screen. Hello?
Excuse me, sir. That was a question from Kishan, sir.
Kishan, you read once again. You read once again. Read it once again. Abhishek, read it once again.
Yes, sir. How
Read.
is it different production machine
How
and
it how
development machine?
development machine? What do you mean by development machine? Right? See, okay, okay. When you look at the mechanical engineering or electrical engineering, right, the process of product development differs. But when you look at the software product, okay, we classified as a product engineering process, main category, which deals with the development process. The development includes requirement engineering, design engineering, programming, testing, deployment. That makes one part of product engineering. Product here, when I say that one, is software product, right? And about the project, it also involves the project management process, which includes, okay, cost estimation, resource management, people management, right, all the things, okay, scheduling and all these things. Then the product engineering involves configuration management, where you develop different versions and all, right? All that versioning and all, how do you manage? All this entire thing constitute product engineering process. And the other major thing is process, whatever we follow, they themselves will get managed, right? For example, you are appearing for examination. Appearing from examination is product engineering process, and it has its own way. Collect a hall ticket, right? Then check all the things, right? Then get identity card, write it. All that will become a part of development process, right? Project management, people management, where to sit, how to sit, where to see, where not to see, when to submit, when to take, receive. All that is a project management process. How much time is required? Configuration, right? It is something like that. Then process. Till today, you were doing about the offline examination. Now you're doing online. So there is a process change in the process from offline to online. That is nothing to do with the development process. There is nothing to do with writing things, but the way that is being done, it differs. That we call it the process management. So this is we call as software process, right? Correct. So we focus on software product related things, right? Not mechanical product, electronic product, though the procedure almost remain same. Correct. So Abhishek, I think I have answered the question.
Yes, sir.
Now the session is getting closed in next 5 minutes. Until that, we'll continue. And once it closes, that one automatically the class ends. Got it. So any other question until that, until the session closes automatically. Any question, Abhishek? There in the chat box.
No, sir, no.
Okay, in that case, with this introduction about the course, we will begin the first chapter in the next class. And please remember, tomorrow, all of you, remember tomorrow at 10 o'clock, we'll have one session of 1 hour. Please join, right? That's because I have taken introductory introduction to this one, something beyond. If I go as per the book, I don't need extra class. But if you want me to tell something comprehensive, complete and all, I need to take few extra things, few extra information and few extra hours also. So I request all the people, right? Tomorrow, 10 o'clock, there will be a regular class. Please join. So with this, I'll close this introductory session on what is software engineering, what all the things that we are going to do. And tomorrow we'll see the first chapter. Tomorrow at 10 o'clock, critical systems and software process. Right? So that's all today. We come to the end of today's session. I'll stop sharing the screen, right? As many as 64 people have participated in this, right? Thank you. Keep attending the classes, which will make your life simple. You get a good grade and you are well prepared for the placement, both, right? Don't miss the classes. Today evening I'll be putting the video of this class and also the PPT used in Google Class. Please refer it for second reading, or people who have missed the classes. Thank you one and all. I'll be ending meeting. You can ask if you have any doubt in the next class also.